one of the most important concepts, I think, in all of general chemistry is the idea of breaking bonds requires energy and forming bonds releases energy. And we can really illustrate that with this simple pair of magnets right here, where I have to put energy in to pull these magnets apart from each other. And if I release the magnets, they'll be attracted to each other and release energy. Again, energy in to pull the magnets apart to overcome those attractive forces. But if I let those attractive forces reach your conclusion, they attract together and energy is released. Okay, now we can take this idea and bring this into play for various reactions. For example, if we consider taking two hydrogen molecules and an oxygen molecule and combining them together to produce water, okay, and I'm not talking about multiplicity of the bonds or anything, I'm just talking about numbers of interactions. Here I have a hydrogen and a hydrogen interaction, hydrogen and hydrogen interaction, oxygen interaction, 3 interactions, okay. Here in 2 water molecules I have 1, 2, 3, 4 interactions, okay. So I have, in going from, and in both cases I have 4 hydrogen atoms and 2 oxygen atoms, okay. And if I go from this to this, I have a net gain of an attraction, a net gain of an interaction. I have a net gain of a bond. And remember, forming bonds releases energy. So if I go from these to these, I have energy release. If I take the water molecules and go to hydrogen and oxygen, I have a net loss of an attractive interaction, a net loss of a bond, and I have to put energy in. And we can exploit these ideas in fuel cells, okay? And in a fuel cell, what we can do is, well, one thing we can do is we can do, sometimes use it to do electrolysis. And what I have here is a little car that's driven by a fuel cell here, and there's water across the electrodes of the fuel cell here. It's acting as a battery. I'm doing an electrolysis cell right now. What I'm doing is I'm taking electrical energy from these 2 batteries and using it to split water into hydrogen and oxygen gas. You might be able to see the bubbles as the hydrogen and oxygen gas is forming inside this chamber. By the way, I don't necessarily need to use batteries. I can also use a solar cell. It's just the weather is not exactly cooperating right now with that. Okay, but what I'm going to do is I'm going to disconnect the electrical power source and now reconnect this, and so now the hydrogen and oxygen gas are going to recombine on these electrodes to produce water, okay? And again, there's that difference in the number of bonds. By the way, I should also point out that this, all of these bonding attractions have about energy in the range of about 400 to 500 kilojoules per mole. So this allows us to sort of count bonds and not have to worry about necessarily the magnitude of the bonding attraction. Okay, so I'm going to connect this up, connect this here, and you can hear the little motor running here, and away we go. Car drives off to wherever it wants to go. Again, because we have hydrogen and oxygen combining across that fuel cell to produce water and producing electrical energy along the way. Now, there's also other forms of energy that can be produced when hydrogen and oxygen combine to produce water. What I have here is a little balloon filled with hydrogen gas, and what I'm going to do is I'm going to light that hydrogen gas and combine it with the oxygen in the air, and you'll see there's an energy release in this fashion too. And that's how we get energy out of chemical reactions.